Assalamu alaikum everyone. I'm here with the next tutorial. This time we will be doing, since we did experiment number 7 and experiment number 8, that was series circuit and parallel circuit individually, separately. This time we'll be doing a combination of series circuit and a parallel circuit. We'll be doing it in two ways. One we will be doing on the multisim software, and the second we will be doing either on the hardware, or we'll do it periodically and we'll compare our answers if there is a difference between our answers or not. How we solve the circuit theoretically and how we solve on this multisim software. So this is the experiment that you will be doing with me in the coming class. Make sure you see this tutorial, complete the multisim part of it, and the theoretical part we'll do when we meet in the class. So this is the circuit that we have. This circuit is neither in the parallel configuration nor in a series configuration. It's a combination of series and parallel circuit. You can see R1 and R2 resistor are in parallel, and this R3 and R4 resistor in series. So to make the circuit short, or we can summarize it how we can add the values of R3 and R4. This is where it becomes in series, and then we have another resistor here, R2. So the parallel combination of R2 and R3, and then you add them up. This is how the circuit would be used. So how we will be making this circuit? It's simple. We have four resistors, R1, R2, R3, and R4. We need to find the voltages across R1, R2, R3, R4, current, the total current of the circuit, the current resistor R2 and current resistor R3 and R4. So we'll go to the multisim software, place, component. We'll first take the DC source. We'll write here DC, and here's the DC power. Okay. Okay, I think we've selected the wrong one, DC power. Okay. The value of the DC source is 12 volts, fine. Then we'll take the resistor. We write here RES, here cut resistor. We have one resistor, we got the second resistor, we got the third resistor, and we got the fourth resistor. Last thing that we need to select is the ground so that our circuit can work fine. Here's the ground circuit. Now we just need to make the connections, make it proper so that it looks good. Rotate it clockwise. This one, make it in line with the other one so that our wires doesn't get tangled up. Make okay, and make this parallel one. Okay, so let's just first make the connection, and then we will change the values as we. Okay, this one we need to bring a little down. This is fine. Bring this one here. Connection here. Then it goes connect this connection, this one, this connection with this. Okay. Here there's an issue there. Control C, Control V, move it. Fine, wasn't looking good. That's why I have placed it. Change a little orientation. Here's one connection, and here's the second connection. This is this is how our circuit is. Now you change the values. R1 is 1 kilo ohms, R2 is 1.5 kilo ohms, this is 1.5. So I'll change the value. Double click it and value from here. Next we have R3 as 3.3 kilo ohms and R4 as 560 ohms. This is 3.3 kilo ohms, and this one is 560 ohms. Let's just see if the all the values that we have used is correct or not. Here it is: 12 volts, 1 kilo ohms, 1.5 kilo ohms, 3.3 kilo ohms, and 560 kilo ohms. I'll just cross this one. Last thing that we need to is to connect a ground. The ground is being connected. So far so good. We'll run the simulation, no errors. This one is running fine. Now we need to find the voltages across the resistors. We'll grab the multimeter from here, place it here, connect it across the resistor. This is how you connect across the resistor. You run the value, you go to this thing, you go to the voltage, and DC voltage is given at 5.769 is the voltage of resistor R1 across R1. We'll stop the simulation. Let's just put all the resistors here, all these ammeters here to check the voltages across all the components at once. This is how it is. Where I want to check is across this one, across this one, across this one, across this one. Move it a little bit here. I need to check the voltage across R2 also. So here's are my resistors. I'll open the multimeters. Here's one. This one is the second one. Okay, this one is the third one, and this one is the fourth one. Run it, and here are your values of the voltages coming. Add them up. This has to be equal to 12. That's coming. If this is it will not come as 12 because this it's in a combination. So if I found the voltages across all the let's say the resistors, and this is what you need to do, the voltages across all the components. And the last thing that we were supposed to do was the find the currents of it. So follow this tutorial, find the voltages across the resistors, find the voltages, the current that is in series. Let me just tell you how you'll find the current. If I just erase all of these, since I've told you before, current is measured in series. So you break this branch, you bring in a meter here, you put it here, you connect it. Now this one is in series, you just change it to amperes, run the simulation, and here's the current that is flowing in this circuit. That's the total current of the circuit. This current will be split into R2 and then into R3 that you need to find, you need to find and complete the table. I hope this tutorial is easy and you all can complete this. Please do this one, and then before coming in the lab, so that we can do the theoretical values and find the difference. Thank you so much. Allah Hafiz.